So good morning everyone. In this lecture we are going to discuss about the next important topic in operating system, which is CPU scheduling. So the CO2, it completely covers analyzing CPU scheduling mechanisms for diverse scheduling criteria. So we shall start this lecture with the topic of CPU scheduling. So what is scheduling? The usual vocabulary meaning of scheduling is prioritizing the task that we do. So in our day-to-day life we prioritize our task, and depending upon the importance we prioritize our task one by one, and also based on the time limits that we have, we usually choose which jobs to do first and which to do the next and which to do at the last. So similar to that, in the system you are having n number of processes, so we need to decide which process to get its execution in the CPU first, and which should get next, and which should get at the last. So this is how we give the process the control of the CPU to a particular process, and we get its execution done. So for example, we have seen different types of processes. There are single processor systems and also multiprocessor systems. So in single processor systems, so it is obviously it is known that we will be able to run only one process at a time. So and in that case it is not necessary to do this scheduling. But in case of multiprocessor systems, there are n number of processes available. So we need to decide which process to must get the CPU at which time, and how long that process must be present inside the CPU, because sometimes the process may be in need of some IO request in between its execution. So at that time what happens, the process usually what it does means it will hold the CPU with itself, and it will wait for that IO execution to happen. So how long as it has to wait, so that much time the CPU will be held by the process which needs that IO request, which is in the process of that IO execution. So at that time the CPU is just sitting idle. So we as a good performance to execute, to have a good performance, a system performance, the main criteria is to have a complete CPU utilization, that is 100% CPU utilization. But imagine that your CPU is sitting idle for more than 20 minutes or 30 minutes. What happens? So it is of a great deterioration to the system's performance. So in order to overcome this, we are going for this type of scheduling. So there are n number of scheduling algorithms available. So based upon certain criteria, we need to choose which scheduling can be done at which time. So for understanding the different scheduling algorithms, we need to know usually a process will be in either any of these two bursts. That is, it can be in either CPU burst or it can be in a IO burst. So whenever the process is getting its control to the CPU, then we will say that the CPU is the process is being executed in the CPU. So at that time we will say that this process is undergoing a CPU burst. And when it is requesting for some IO action, IO activity, so at that time we will say that it is in need of an IO burst, that is it is having its IO burst. So either in CPU burst or in IO burst, the process will be in just any one of these two states. So at the beginning of the process, we will be assigning a process to the CPU. So first it will start with the CPU burst and then the IO burst. So alternatively the CPU and IO burst will be happening. So this diagram, it shows a clear explanation about what is the CPU burst and how the alternate executions of the CPU and IO burst are happening. And at the end we will be, as we begin every process execution with the CPU burst, we end it with the CPU burst only. So it can be either termination or it can be either an abortion. So the next is the different terms and terminologies that are associated with the CPU scheduling. We need to know that, and there comes the first main criteria, which is the CPU scheduler. So we have decided to run some of the processes in the CPU. So there will be n number of processes. So as we have discussed, there will be we are talking about a multi-process system. So definitely there will be n number of processes available. So the scheduler is the one which is going to decide which process it has to choose and give it and give the control of the CPU to that particular process. So that selection process is done by that CPU scheduler. That is the one which is going to decide which process has to be chosen from the n number of processes available in the ready queue. So it also has another one name called as the short term scheduler. So we can either name it as CPU scheduler or the short term scheduler. Then what is a dispatcher? So the CPU scheduler, it will choose any one process from the n number of processes, but the dispatcher is the one which gives the control of the CPU to that particular process which has been chosen. So maybe some other process may be executing in that particular CPU. So at that time the dispatcher, it has to give the control of the CPU to the newly coming process which has been selected by the scheduler at a particular instant of time, right? So that is the task of the dispatcher. But this type of context switching, it cannot happen all on a sudden. So at that time there will be some time of delay, some sort of delay. That is known as dispatch latency. That is called as dispatch latency. That is the time it takes for the dispatcher to execute that, to stop the execution of a process which is happening, execution which is happening in the CPU, to stop that process and start another running process. That is there will be a small time gap. That time gap or that latency is called as the dispatch latency. So at which before knowing what are the two different kinds of scheduling, we need to understand what are the different circumstances under which these decisions has to be taken. So there are four different circumstances which are available to decide which type of scheduling is better than the other. So we can't stick on to a particular kind all the time. It depends upon the application. But before going to the two types of or two kinds of scheduling, we need to understand what are the different criteria or the circumstances which are in need of this type of CPU scheduling. So at which time the CPU scheduling it comes into existence, that we have to understand. So the first case is when a process switches from the running state to the waiting state. We know that the process will be in any of the 5 states. The different states we know, we have already seen in the previous lecture. It may be in a new state, it may be running state or ready state or waiting state, or it can be terminated. So these are the different states the process will be available in. So the first state, the first circumstance that we are going to discuss here is when a process switches from the running state to the waiting state. That is, during the running state, the process will be inside the CPU, that is, it will be in execution, right? And when it will switch from the running to the waiting state, whenever it needs some IO request, it will be switching from running state to the waiting state. So this is the first case, right? And when you see the fourth case, when a process terminates, so at this point, definitely the process, after a smooth execution, it ends its execution and it will get out of the CPU. So the first and the fourth case are too obvious. That is, there is no choice for any other process to enter into the CPU, and only the process which is running is getting its hold of the CPU at any instant of time, right? So these two cases are too direct and too obvious that we don't want to worry about any other process, right? There is no other choice. Second choice is not there. That is the case of the first and the fourth circumstance. Whereas the second and the third circumstance, please see that when a process switches from the running state to the ready state, and when it switches from the waiting state to the ready state, in both the cases the process is actually being interrupted, or actually it is in a waiting state and it is getting into the ready state. So when it is in the ready state, the next state to the ready state is execution only. We know that is running state. So during moving off from a ready state to a running state, there may be different choices, because the process which may be interrupted or which is ready to execute after the completion of IO, it may be given the chance to get inside the CPU, or some other priority processes, or some other process, or a new process, it can be given the priority to enter into the CPU, right? There are two choices which comes into existence here. Whereas in the first and the fourth case, there is no other choice. Only the process which is waiting that is getting from running to waiting state, it will be directly entering into the CPU. Or here, definitely after the ending of the process, particular process, we will be taking the next new process which is available in the ready queue, and we will start our running execution in the CPU. So these two cases are too obvious, whereas this and the second and the third case, there may be two choices, that is either the process which has been interrupted or the process which has completed the IO, it may get the control of the CPU, or the new process which is present in the ready queue, it may also get the control of the CPU. So there are two choices which is prevailing here. So these first and the fourth circumstance, it paves a way for non-preemptive scheduling. There are two kinds I have mentioned, right? So the two kinds of scheduling, types of scheduling, there is two criteria which is present for scheduling, is either it can be a non-preemptive or it can be a preemptive. So in the first and the second case, we never take the process which is running presently in the CPU out from its control. We don't take it without the complete execution of that process. We ourselves will not take that process away from the CPU in the first and the fourth case. Whereas in the second and the third case, there are two choices available, right? As we have discussed, there are two choices. So the process which is presently executing in the CPU, it may be taken out for any reason. For any reason, please underline. So it can be taken out of the CPU and the control may be given to some other process. So at that time, we are not letting the process to continue in its execution for the entire amount of its running time, right? So this is called as preemptive scheduling. So we may think that non-preemptive scheduling is the most advantageous because it is getting the CPU throughout the entire period of time. No, it is not the case all the time, because sometimes the higher priority process may be available, or the currently running process, it may have a long running time. So at that time, we may not make the other processes wait for a long period of time. So at that time, we may enter into starvation. Okay, so that should be avoided. So non-preemptive is not always the best choice. And also when it goes for preemptive, it is highly it costs much. The reason why I mentioned here it costs much is, for example, the n number of processes are there. So one process may imagine that you're having a shared memory. So one process may write to a memory, and if it is being doing that writing process, if it is writing some operations, or updating some variables which are present in the memory, and if it is half done, during that time you are taking that process out of the CPU and giving the control to some other process. What happens? So when the next process, it reads the value which is being half done by the previous process, we will be getting inconsistency data, right? So this is the disadvantage of preemptive scheduling. So we may not come to conclusion that either preemptive or non-preemptive is the best. So depending upon the situation, it varies. So these are the two, preemptive and the two types of scheduling, preemptive and the non-preemptive scheduling. So with this introduction for the CPU scheduling, we may enter into the different scheduling criteria. So there are n number of scheduling algorithms available. So the different scheduling algorithms, it can be chosen depending upon the application and also based upon the different criteria which is available, that we are going to see one after the other now. That is the CPU utilization, throughput, turnaround time, waiting time, and the response time. So what is CPU utilization? So we know, as for a good performance of the system, the utilization must be always, it must be 100%. This means that the CPU should be kept busy all the time. Always we need to make the CPU to hold some process, and it should do some execution. So practically it is not possible to get 100%. So it varies from somewhere from 50 to 95%. So next is the throughput. That is, throughput is nothing but the total number of processes that are getting completed per unit of time. That is called as a throughput. So for when the first criteria is met, automatically the second criteria will also be met. That is, if we keep this CPU that is busy all the time, definitely n number of processes can be executed and get completed per unit of time. So that is the number of processes which are getting completed per unit of time. That is a throughput. And turnaround time. So this is the important scheduling criteria that is always when you look at a particular algorithm, a scheduling algorithm, we will be looking up for this turnaround time. That is, the turnaround time is a time computed between the submission and the completion of a process. That is the difference between the time between the submission and the completion of the process. So the total time which is spent throughout by the particular process in the system, not alone in the CPU but also in the ready queue, but also in the dispatcher, but also in the scheduler, and also during the execution. So that complete time, how much time it takes to get its execution done, starting from the creation till the end. So together we will be saying that it is a turnaround time. So the turnaround time, if it is minimum, then we can say that it is a good scheduling algorithm, right? So next is the waiting time. So waiting time, as the name suggests, we can be sure that where the number of hours that the process is spending in the ready queue, that is to make its IO done, or to get some resources. So total number of time it is spending other than the time which is it's getting inside the CPU's execution, all the other time, that is it is waiting for some resources or the input output operations to get done, all the times together, if it will give us the waiting time. So the sum of the period spent waiting in the ready queue to get a chance for execution. So that must also be minimum, because we need to have, in order to have maximum throughput and maximum CPU utilization, this waiting time should be minimum. Only then we will signify scheduling criteria as a best one. And the next is a response time. So this is somewhat different from the turnaround time. In turnaround time, we will be pointing out to the complete time that is spent, that is till the completion we will be calculating. But in response time, we are speaking about only the time to receive the first response of from that process, not its completion. So here we need to note the difference. It is a time from the submission of a request until the first response is produced. We are not talking about the entire completion of the process, but just from the time we have submitted the process till the first response that the process has produced. That is known as the response time. So one best example is the ATM is an interactive system which is used in banks for withdrawal of money. So even though we have started the process, so actually the turnaround time should be completed until till we get the money back from the ATM machine, right? So that is only the completion time. But once you have inserted the card inside the system, your process has been initiated. So you are in the process. So the first response that you get by getting the messages on the screen, you will be getting some response. So that is called as the first response time. So that time, the time which you start that execution and the first response you receive from the system. One best example other than this ATM is imagine you are clicking onto a video on the system. So in the background the process has already been started, but there will be some sort of delay until you get the first screen, the first frame on the screen. So that difference is called as the turnaround time and the response time. So turnaround time is a completion of the process, whereas the response time is the time it takes for giving its first response. Okay, so depending upon this response time, it also should be minimum. Okay, so these are the different optimization criteria for any CPU scheduling. So the maximum throughput should be there and maximum CPU utilization should be there. Only then we'll be getting minimum turnaround time, waiting time, and the response time. So based upon these, we are having n number of scheduling algorithms that we can see in the upcoming classes one by one. Thank you.